What's up, guys? It's Minx, and today we're going to be starting a new project together. I know I've kind of put some code here together. This is sort of an example of where we're going to be headed. And instead of doing a code review where we watch the code review and then we, or you guys, I review code and you guys watch, we're going to be coding together. So I recommend that you follow along, boot up Visual Studio, and we'll start when I create a new project. Before we get into that, I want to explain what this project is. Oops. How's that? Um, so that you're kind of aware of what we are. Title should be pretty self-explanatory, but doesn't have all the details. So this will be a 2D platformer. How original. There will be a level designer, so we're going to be building a level designer. We can literally build levels. Levels will technically be able to be uploaded to a source, then downloaded from that source with an in-game, like using a UI, sort of like Mario Maker, a Little Big Planet, where you like browse for levels that others have made, and you can play them. We'll be implementing advanced movement, so walking, running, sliding, crouching, wall jumping, stuff like that. There'll be enemies and hazards. There's going to be a camera system that follows the player. That's not too difficult, so that'll be fairly easy. I don't even know I had it in a separate line. When I originally wrote it out, I thought it was going to be a bit more difficult, but it's not. And then we'll have advanced input. We can already see things. This makes it look simple, but it's actually pretty sick. So we'll have an input system and all that good stuff. So let's. I haven't really like built out the whole thing in here. I've done a lot of this in JavaScript already, so for the first few videos, things will be going fairly smoothly. Let's go ahead and start. So for now, I got this set up. So it's just a basic thing in 2D here. We just run around and jump and got collision. The big thing here is there's no engine. We're not using like Unity that like handles collisions for us automatically or anything like that. We are, aside from the layer of Windows forms between like us and drawing on the screen and all that stuff, we're doing everything from scratch here. So it's kind of a learning, what do you call it? A learning exercise, we could say. So with that said, let's go ahead and make a new project. We're gonna, this one's gonna be a relatively longer video. So like I want my videos to be like 20 minutes max. They're easier to follow along with without getting too bored, so you don't have to stop halfway through. This one's going to be more like 45 minutes because there's just a lot to get set up in one video, because it's going to take us 20 minutes to get the window set up properly before we even draw something to the screen. So this will be a longer video. I apologize in advance. Let's go ahead and choose our project type. So it's going to be a console app. We want to make sure it's console app.NET framework. So make sure, if you don't see it here on the left side because you haven't made one, do a C#, all project types, and then just type in console, and it should be the only two above the line. Make sure you select the .NET framework. Name it whatever you want. I'm going to call it game with no engine tutorial. Okay. Once you got that done, you should just see a static void main with nothing in it. If you hit start, if you've done it right, you should just have a console that pops up and goes away. If you have that, you've done good so far. I'm going to do my best to make sure this is readable and go slow enough so that you could be following along. If you're following along and you feel like I'm going too fast, please let me know. So let's go ahead and make a new folder here. I'm going to call it game. I don't really know what the best thing to call it is. Maybe we put subfolders in it later, but this is where everything is stored. Program.cs doesn't really do that much other than tell the game to start. And inside a game, we're going to make a new item, and we're going to call it, I call it game window. Again, same thing. I don't know if there's a better name for it or anything like that. Its primary thing is that it's the game window, but it is also, it's basically what our engine is. This is where we handle a lot of stuff. So this is going to be a relatively large class, and it's easier to handle it here than it is to like break some of these things up into different classes, and you'll see why. To start, let's go ahead and set up a couple settings here. This is actually our game window, so let's start with some window settings. So private vector2, and that should come up red right now. We'll get that fixed up in a second. Screen size equals new vector. Oh, we don't need to do that yet. We'll do that inside the constructor. If vector 2 is coming up with a red because it's not added, go ahead and use system.numerics. And then we'll do the same thing for our string, not internal, or for our title, private string title. And for window settings, that's it for now. Let's go ahead and do a constructor. Now, if you're not sure what a constructor is, it is essentially what gets called when you create a new instance of a class. So if I were to go back into program and say game window equals new game window, this calls the constructor of game window. So if we go back, and it's defined by just saying using the class name as a function, and it'll turn green if you've done it right. So, man, that annoys me. Okay, so in here, we want to do vector 2 screen size and wow, I'm like saying or typing what I'm saying. String title. We want to do our two variables that we made up top as inputs or as parameters. And then just say this dot screen size equals screen size, and this dot title equals title. So I made these the same name on purpose to kind of outline this here. So when you use this in front of a variable, it references the variable or the instance variable rather than, for example, the parameter. It's very distinctive. Otherwise, if we were to if we were to make this a little less confusing for the system, we could change capitalize or change the labeling somewhere, change one of the variable names, and then we could get rid of this and it'd be implicit. But we'll make it explicit. So next up, next thing we need to do is actually create the window, because right now all it's doing is creating the console. We need to tell it to actually create the window where the game runs. Now, the window where the game runs, we need it to act a little differently than a normal form, because it is using the forms thing. So to make that happen, let's come up here and make a new class. Let's call it class canvas. That's usually what we call these when we work with these. You know, like if you use Pygame or something like that, I'm fairly certain it's called canvas. I know in JavaScript it's definitely called the canvas. So in here, we want canvas to actually inherit from form. So do space colon form, space colon space form. And form probably won't, because we're in a console app, it won't be included by default. We'll do the same thing we did with vector 2 and using system dot, specifically system dot windows dot forms. Okay. And we're going to do a constructor for this as well. All this is going to say is it's going to change a setting. We could theoretically just do that down here, but it's easier in case we ever want to do anything else with this, because technically this is going to be this class is going to be engine-esque, so you could make different games off of this. But all we're going to do is say this dot double buffered equals true. So what does that do? Let's hover over double buffered. So it says it gets or sets a value indicating whether this control should redraw its surface using a secondary buffer to reduce or prevent flicker. So by default, forms aren't set up to be refreshed as fast as we're going to be refreshing it, and definitely not the whole screen like we're going to be doing. So we need to. So when that happens, you get a potential issue with flickering. And this doesn't really mention stuttering. I imagine it also helps with potential stuttering, at least visual stuttering. So this will help fix that, because we're going to be refreshing it at least 60 frames per second for this. It's a 2D game, we'll probably aim for higher. So that'll help with that. We'll see have less potential for issues down the line, especially when if performance becomes an issue. With forms, again, going back to the fact that they're not designed for this, we may have a performance issue that we need to worry about a little bit of optimization. But if it comes to it, we can deal with it. So for now, let's go ahead and define our window. So let's come up above our constructor and make a, let's see, so it's the window. Nothing else needs a reference directly to this, so we can make it private window, or canvas, and call window, or I'll call window. And then we can say window equals new canvas, and instead of doing the parentheses, we're going to open close curly bracket. This allows us to set it up without saying window dot attribute or window dot field or whatever. So we can say size which is going to come up bad right now, which we'll fix in a second. Equals, actually we'll have to fix it now. Let's go ahead and do that. Type in size, and it knows what it is, but it also doesn't. It's kind of weird. We'll take it from system.drawing. Size equals new system.drawing.size. And size doesn't know what a vector 2 is, so we'll come back to that in a second, because there's also an extra thing we have to do. And then we'll say the text is equal to this.title. So the text is just the stuff that comes up at the top of the screen, or at the top of the little thing up there. So for size, it takes two overloads. I happen to know what they are. It's a width and a height, essentially, which is essentially the default since it can be resized at this point. I wonder if there's like a resize. Oh, we'll look at that later. So window or dot size, and we want it to be this dot screen size. However, comes up argument 1 cannot be converted from vector 2 to system.drawing.point. System.drawing.point is, I wish it would say here. Let's see if we can get this to pop up just for here. So we got width and height. So that's all we need to know is we got the width and the height. And it doesn't really say much else for us. E.x, E.y. So we know it's taking two numbers. So let's do this dot screen size dot x because that's the first part of the vector. This dot screen size dot y. And it's still tossing us errors, but it's different now. Now size isn't freaking out, but these are. It says cannot convert from float to int. To fix this, we need to cast. So a cast, in this case, we're going to explicitly cast, is done by putting int or int inside of parentheses in front of the variable we're trying to cast. It's an explicit cast. All we're doing is telling C# that we are, or the compiler, that we are okay with casting this and that we are accepting that we're probably going to lose some data. For example, if this were like 4.3, it's going to get cast to 4. Now in our case, we have full control over the screen size. We know we're going to be passing integers, so it's not an issue. But okay, moving on. Next thing we want to do, so we've got our window set up. We got to tell it to actually create the window. So just come down here and say application.run, and we type in window, and it will run our window for us. Now, considering we've already, we got to actually go back to program here. We get an error because we added a couple parameters to game window. We have to tell game window what those are. So make a new vector 2, and then we'll say test title. So in the vector 2, you can do whatever size you want. I'm gonna do 1280 by 720. Because it's a pretty good aspect ratio. I don't know if it's exactly 16 by 9 or if it's close to it, or I mean it feels like it's close to it, but it also doesn't take up the whole screen. But now, if you've done that, you should be able to hit start, and we're good. So it may seem like it may feel like we're already like pretty close to where we are in the last video. We've already got the window up. You know, all we need to do is drop a player in here, drop a floor, and we're good to go. We got to tell it to do all of that. And it's not even considering the fact that we haven't even gotten a screen to refresh yet. The screen hasn't refreshed a single time. It opens up with default and then it doesn't do anything else. So let's get that set up next. So let's go ahead and come down here and make a new void. We'll do private void game loop. So what this is going to be essentially our event tick, or whatever you want to call it. So if you use a event tick, it's our update, or what it's called every frame essentially. But this is the engine side of things. So this will be like, so when a Unity engine has its gives its objects the ability to call update on GUI, late update, and all that stuff. That's kind of what we're going to be creating here. This is where this all gets controlled. So we get to say, do you want to draw first? Do you want to update first? Do you want to draw, then update, and the next frame draw what you updated? You know, stuff like that. So before we go into the game loop, let's go ahead and do a, I'm going to make it public. No, I don't think it needs to be. We'll see. I don't think anything else should be in control of this, but I will see. Game state equals 0. And I forgot to public int game state. So game state is essentially not like not like is the player in the level, is the player at the main menu. No, nothing like that. This will be like, is the game in setup? Is the game loaded? Should we be refreshing? Is the game shutting down? A game state like that. And we can say if game state equals 1. Then in here, or well, not if, it's while it equals 1. So while game state is equal to 1, we'll be refreshing. And I want to do one more thing here. We're going to do a private void onload. And then we're going to call onload before this. There you go. And in onload, for now, it's not going to have much going on at the moment. This is going to be where we do like testing stuff, like onload. We're just going to spawn our objects for now until we get down later where we want to spawn them with a level, you know, for example. So onload, we'll say game state equals 1. And then we'll call onload here, onload. Actually, no, we won't call that here. Onload will be called when we run game. That's my bad. So, it's out of here. So, now let's go ahead and create our other methods for updating updating the GUI or whatever, updating visuals. So, this one won't actually be the one that updates it, but this will be used to down the line. We might not use it, we'll see. But this will be used down the line for when the screen refresh happens, or not when, when the screen refresh is about to happen. So we'll say on draw. Then we'll do another one, private void, and I don't know if I want to call this one just update. We'll call it on update. We'll keep the name consistent. On update. Is there anything else? No, not from this. Okay, so we'll say on draw, on update, and on draw we're gonna put the refresh screen here. So this is gonna tell the screen to refresh here, in between this. So it's gonna draw it, it's gonna refresh the screen, and then it's gonna update everything, and then the next frame is gonna draw, refresh that update, and then it's calculate. The order doesn't matter too much. As long as I think the only thing that would really matter is probably not putting the on update in between the on draw and the other thing. Though in this case, it doesn't matter yet. What it does matter is knowing the order that you have it, so that way you're not doing things on an assumption that it's a different order. Anyway, so we've got this set up. Let's go ahead and make this not freeze everything up. So the next thing to do is say thread.sleep. If thread doesn't come up by default, you could do system.threading.thread, or just come up here and select this and align thread. You just do thread.sleep. Now, if you've done this with Python before, then you'll probably use like time.sleep, or just have it out to just time, or just sleep. And you do like 1 divided by 60 to get 60 frames per second, because that's 1 is 1 second. And here we use milliseconds, so if you ever sleep, it's into milliseconds. So you could do 1000 divided by 60 for 60 frames per second. For now, we're just going to do 1 millisecond, so just put in 1 there. That'll be enough. We're going to do something else to also make this a little better, so we'll see that in a second. Or a little, like, less impactful, because I think even right now, if we were to do this, it would just kind of make everything super laggy. Oh, wow. The function's not getting called. Excuse me. Let me, game loop. Let's see what happens if I do. I think it's really laggy. It doesn't even get to the application number, because the game loop runs, so that's okay. Let's go ahead and set up our thread. So, if you've made a thread in C#, or not a thread, a TCP server listener, or a TCP listener in C# before, you'll likely have worked with dethreading, or listening on a different thread, so you don't freeze up your GUI or something. And that's how we're gonna do this here. So, make a private thread, call it game loop thread. It's fine. Just game loop, game thread. Actually, I'm gonna call it game thread. And then on the game thread, we're going to come over here and say game thread equals new thread. And thread, let's get rid of this game loop, because this shouldn't be running. If we hover over thread to the thread, it takes an input. It takes something called a thread start. That's not very clear here, but we'd happen to know it is a function or method, so we can just pass through game loop. And what this will do is it'll create a new thread and have it run game loop rather than rather than something else. It'll run game loop new thread, and then we can say it's already got it here. Game thread does start. So now what'll happen is actually we can go ahead and come in here, and we'll even put this on update. Console.writeLine. I am updating. Alrighty. So we should actually be good to start that and see it coming up. So it's updating every millisecond or every other millisecond, so that's good. We're going to cut this out here because I don't like printing every millisecond. It's annoying. So the next thing we want to do is get our window to refresh. So window's created, and we have a method that gets called every other millisecond, but window is just stuck there. It doesn't update unless we tell it to update. So I'd go over the documentation right now, but it's not worth going over. You can look it up. There's 3 options. There's like invalidate, there's refresh, and there's another one. You do like invalidate and the other one, or you just call refresh. So we're gonna do refresh. So in game loop, we could just say window.refresh. Now I can already tell you this is gonna toss an error, but we're gonna give it a shot anyway. So it says cross-thread operation not valid control. And the control is the window. So cross-thread access happens when you create a new thread and then access something that's not on the same thread. So that's what we got to fix next, and it's not a hard fix. Again, I would bring up the where I found this, but it's not worth it. The code's not too interesting. We'll just talk about it a little bit. And why we do it. So instead of doing window.refresh, we say window.begin evoke. And we put in here a new, well, we don't have to specify new, say method invoker. And it is a delegate. And in here, this is essentially just the action that we're taking. And in here, we say window.refresh. So this will cross the thread. To be honest, I don't understand what's going on under the hood too much. You can see here represents a delegate that can execute any method in managed code that is declared void and takes no parameters. Delegate essentially just sends something across the thread. It sends a message, and since it can't pass through parameters, if I'm not mistaken, there's a way to pass through parameters, but we're not worried about it here. So this will refresh the window. Now, we're still going to run into an error. Let's start this. Let's go again. See what happens. All right. Invoke or begin evoke cannot be called in control until the window handle has been created. Window handle hasn't been created because we start the thread before we run. Obvious fix would be to stick the application not run before the game thread, but that causes issues. I'll be honest, I'm not sure why, I just know it causes issues, because it doesn't, right? So instead, we're just going to toss this in a try loop. Or a try catch statement, whatever. I don't know. Just toss all this in here. Catch. And we don't really need to type anything in this. I need to type my do nothing. Doesn't really matter that much. Okay, so that fixes that. Now if we start, nothing changes. It's refreshing now. That's the important thing. It is refreshing every other millisecond. So let's go ahead and close out of here. Let's go ahead and change the background. So how do we change the background? Window.color, back color. That's kind of stupid. Every frame? No, we don't do that. At least not here. So when window gets refreshed, it calls something. It has an event handler or a event handler. We're gonna use it. So come up here. I would say window.paint plus equals, and we'll say window paint is perfectly fine. Window paint. So when window gets refreshed, window paint gets called. You're gonna tell me what it does? Occurs when the control is redrawn. Good enough. So, man, excuse me. When window paint is called, it tosses in something called paint event args, which gives us some references to some stuff. So the important thing we want or need is graphics. Graphics is the screen that is being drawn. Essentially, it is it's for all our purposes, it's the window. So we'll call it G because everyone calls it G when they whenever I see like stuff on this, it's called G, so we'll use it. And it's equal to e.graphics. I spelled that wrong. I don't know how that C got there. e.graphics. Okay. And then to change the background, we do, so I like to use something called g.clear. What this will do is clear out everything off the screen, then draw a black background. Color.black. So put this in the very back first, so things are drawn in the order that you draw them. So g.clear, color.black. This specifically specifies, it specifies that the background color is talking about that. So if we draw this here, we could then say draw objects here, draw foreground stuff next, draw in the order from back to front that you want stuff. Whatever gets drawn last is what gets drawn on top. You have to keep that in mind here. So we could create like layers and stuff like that by saying, draw layer 1, draw layer 2, for example. But for now, we got g.clear, color.black. Let's go ahead and make sure this works. So we got a black screen now instead of a white screen, or whatever color that was. So that was fun. How far are we in this? Okay, we're at 26 minutes. Like I said, 26 minutes before we're even ready to draw stuff. Now we can go ahead and prepare to draw something. Excuse me. Let's go ahead and set up a drawing interface. This way, we can, instead of saying for every item we create, draw it here, we're going to create a registry that allows us to draw items that want to be drawn, rather than just having to call a billion things in here. So I would say add a new folder. We'll call it interfaces. And in the interfaces, we'll call it a new item. And the name matters here. You could technically call it whatever you want, but there is a what do you call it? A standard, I guess you could say. So we're doing I'm going to call it, so you start with capital I, then you do what you're calling it. I'm going to do I drawable. And if you create it with this name convention, that's what it is, a convention. You hit add, it'll create an internal interface instead of an internal class, because it knows that, hey, this is the convention you used. You're going to be using an interface. You're going to be making an interface. So in this interface right now, we only have one thing. I don't know if we'll ever add anything more to this, but it was better than inheritance for the inheriting from another class, because there's single inheritance. So we just say void draw. And draw takes an input, which is also relevant. It takes graphics, and again, for our purposes, it is essentially a screen. I call it window. It takes the input of window. So now, what we can do is say, go back to program, or game window, excuse me, and we want to add a list. So we'll say, this can be private. So the lists are going to be private, even though we're going to register on the objects themselves, and we'll see how we do that and why. So private list, this will be of type iDrawable, so of type interface. We'll call it drawables. And then what we can say is, before we even create an object with it, in window paint, we could say for each iDrawable, drawable in drawables. Gosh dang it, I've done it again. Get down there. There you go. We could say drawable dot draw, and then we pass in G, our e.graphics, which, like I said, is our window. And now what we can do, this is annoying. I swear it's doing it on purpose. Is that right? Yeah, it did that shit on purpose. Alright, there we go. Oh no, the whole thing's like offset. Weirdo. There we go. Man, that was weird. Okay. Anyway, the for each got like pushed forward. So instead of wherever I was, I'm not sure where I was. Instead of going into each item that needs to be drawn and calling draw, what we do is we go into the object itself that implements iDrawable and say register with this iDrawable list here, and then you'll start showing up on the screen. And then, you know, you can deregister and stuff like that. So now Drawables is private. How do we get it to, well, how do we get something on it from itself if it's private? Well, we give it essentially a public accessor. So we'll say public void register drawable. And it takes a, it looks like it tried to fill it for me. It takes an iDrawable, we'll call it drawable. Then we say drawables.add drawable. So what we do here is we make it public, and we can access this from other objects now without a direct reference. Or well, we need a direct reference, but we can call it outside of this class. The reason for this is down the line, if we register something, since it's being called from the item itself, so we create like a player and the player says draw me, the player doesn't know to do other stuff. Well, we don't, you know, we might not remember to do other stuff, and there might be other things that need to be done that, you know, that you don't have to do on every object. So when we say register, down the line we might need to say do ABC, then register, rather than doing that check on the player level or on the other object level. That gets done when you call register. That way it's easier. And by making our list private, instead of taking a cheeky little shortcut, we have to do things the correct way. So that's why we do the register and unregister or deregister. So do a public void register drawable, if it would not be in. I'll just copy and paste this over. Looks like it wanted to fill it for me. I'm too cool for that. So we won't do any error checking or anything like that. As of right now, we are assuming perfect scenario because we have full control over this. Even with loading levels, it shouldn't be an issue unless we get some like super complex shit. Then we need some error checking. But now we have register and deregister. So if something is added, it needs to implement the iDrawable interface. And I'm not actually sure what would happen if we tried to add something that's not iDrawable. We'll find out. I'll test it out. So let's go ahead and go into our game folder, and we're just going to add a new item. For now, it's just going to be in the root game folder. We're not going to put it in. I'm going to call this test object. And this one's probably going to be something we use a lot in the future for testing new things as we write code. So we want to, instead of like starting off our player class that we're going to barely be able to do anything with, we're just going to make test object and test draw it and see what happens. So first things first is we're going to make a public test object constructor. And I want it to take the game window game as an input. And we're going to say game window, and we'll call it game again here. That's perfectly fine. It is what it is. We'll say game, or this dot game equals game. So the reason for this is we need to be able to register test object with game. Otherwise, it's not going to work. So we say this dot game, and then we can actually, since this is going to be multi-line, we can say this dot game dot register drawable. This. See what happens. So it automatically tosses an error because this doesn't implement drawable. So let's go ahead and fix that. That's nice. That means it'll prevent us from doing stupid demo. We can say internal test class test object, and then similar to class inheritance, interface inheriting from an interface is as simple as doing colon and then the interface name. So iDrawable. And now that fixes this error, but now we get another error. Let's go ahead and implement the interface member. I'll show potential fixes, implement interface, and that'll pull or create a withdraw. Now, since I intend on using this for a while, instead of just creating the generic, like creating hard-coded stuff here, we're going to put it up at the top. So to draw something to the screen, we need a brush, and it would be my box, I guess we could say, or my visual. Then we could do a rectangle, so rectangle, and my rectangle. So to draw something to a screen, we need a brush, which is essentially the literal thing that we see on the screen. So a brush could be an image, as in a texture. It could be a solid color. It could be a lot of different things. The nice thing about using brush here is, excuse me, there's a lot of classes that inherit from brush that can be used in place of it. So we could test things down the line with it. And rectangle is just a x, y coordinate and width and height. So to go ahead and draw this stuff to the screen, it's actually fairly simple. So we would say this dot, it's my visual, this dot my visual equals new. Wait, hold on. Visual. Oh, it's not a new rectangle. I don't know what I was thinking here. Oh, actually, we wouldn't put my visual here. We'll say this dot my visual equals new solid brush. We don't need to like set it up every single frame. We'll make it. I'm gonna make it blue because I want the player to be white. You can do whatever color you want. It doesn't really matter. And then down in the draw, we say this dot visual box, or not visual box. Excuse me. My rectangle. I was thinking that. Equals new rectangle. And now here's where things get a little goofier, because yeah, we're gonna do it this way. Okay, so we'll say vector 2 to position and vector 2 scale. So position and scale. So again, the rectangle takes 4 integers, a x, a y, and a width and a height. So we need to define those, and I don't want to hard code things because it's easier to say change the position dot x than it is to like create a new fucking rectangle every frame. We have to make the new rectangle every frame, but we don't like have to create a rectangle, modify it, and then use the rectangle. We just tell the rectangle what the new ones are. So rectangle's inputs are this dot position dot x and this dot position dot y, this dot scale dot x, and this dot scale dot y. And all 4 of these toss an error. You know, remember that issue we had before? We gotta put int in front of it. We gotta do that here. We may re-implement the rect class because I know Unity does it, and honestly, it was a genius idea. Where it can take floats instead of just integers, because that, you know, that makes too much sense for it just to be implemented by default. But once you've got that set up, we could say the window, so from graphics, so it's our parameter, window.fill rectangle, this dot visual, or, well, this dot my visual, and this dot my rectangle. And that'll do it. Now we just got to tell it what our position and scale are. For now, we're just going to put it up in here in the constructor, this dot position, it's new vector 2, we'll say 100, 100, this dot scale equals new vector 2, 100, 100. It's perfectly fine. Control S, and now we gotta go ahead and go create one. Back when we did the onload function, this is where we can put like or hide like or just create this for now. We can say underscore equals new test object. Oh, and we have to pass in this. So underscore is a discard. It means we're not going to use this anymore. This will create the test object for us, and then toss out there won't be a variable reference that we need to worry about. It'll just be referenced in the list, and it exists in its own self. So it's good for testing, or in this case, and it can be used for things like, what do you call this? It doesn't matter. So let's go ahead and test it out and see if we got something drawing on the screen. Oh. Looks like we can't use the discard here. Huh. Alright, that's okay. Drawables was no. Oh, that's my bad. We can use the discard. That has nothing to do with the discard. We're gonna hit stop, not the fireball. So Drawables never got instantiated. The list technically exists, but the list doesn't exist. So we'll go in onload, and actually onload is probably a good place to do this. We'll say Drawables equals new list iDrawable. And start. There we go. And now I got a blue square. In the next video, we're going to start working on the player system. I don't know if we're going to do physics. I think we're going to do player movement. We're going to do the input system. Because I don't want this video to go any longer than it already has. It's 40 minutes. I'm glad I was able to keep it down this far. So we're going to create the player. We're going to implement that. We're going to implement input. In the video after that, we'll start doing like physics and stuff like that, and collision and all that good stuff. So try and keep those a little bit shorter so everything's not too excessive like this one is. But we've got some of the basics down. Things will get a little bit more interesting in the next video, I promise. In the meantime, have a wonderful day.